That's right, boys and girls. It's time for one of Sorensen's electronics quickies. No, not that kind. A quick, short lesson on magnetism. This is part of the Electronics 1 curriculum. What is magnetism? Well, geez, I don't know. Look right there. I've got two permanent magnets, two rare earth magnets, and they're holding together with my flesh and my fingers in between them. So obviously, magnetism is an invisible line or invisible force of attraction, and it can be repulsion. Let's look what happens when we flip that one on the bottom over. It repulses the other one. So magnetism is nothing more than a invisible force of attraction or repulsion. Now, some terminology we need to get. Flux lines. Now, those lines of force that you can't see that was holding the magnets together through my fingers are called flux lines. In a typical bar magnet, they leave the north end of the magnet and head to the south end of the magnet. Say what? Well, actually, on magnets, got a north and south end representing the magnetic polarity, just like our positive and negative polarity in our electrical circuits. So that's how that works. So basically, just like the law of charges states, north will be attracted to south, south will be attracted to north, north will repel north, and south will repel south. A couple other definitions we need to talk about. Reluctance. Okay, what is reluctance? Well, let's look at this thing right here. Real exciting stuff. It's nothing but a plastic pen. If we stroke that against the magnet, oh, the magnet's really enjoying that. Does it become magnetic? No, it doesn't become magnetic because plastic has high reluctance. How about this screwdriver here? That's actually a Torx driver. It's already a little bit magnetic. Let's see if we can use one that's not already a little bit magnetic. Make the point. Another screwdriver. He's a little bit magnetic. So let's stroke him. Get him off the magnet. Let's stroke that across the bar magnet, or the earth magnet. See, it's so attractive force is so strong, it's kind of tough. Now he's even more magnetized. All right. So the plastic had high reluctance or opposition to becoming magnetized, and the metal screwdriver became magnetized fairly easy. Now there's another term we need to learn about: permeability. These guys are rare earth magnets. They're going to be magnetic for a very, very, very long time, millions and millions of years. And you can see they have the strong attractive force to those paper clips. Let's put our paper clip there. We just made this guy magnetic a few seconds ago. Let's just beat that out of him. Okay. He is no longer magnetic, so he has very low permeability. This specific metal has very low permeability. Different metals can be more or less magnetic. Okay. Here's an example. That's metal, but it's aluminum. It's not attracted to that at all. Okay. So aluminum has very high reluctance, and if you can't become magnetized, you have very low permeability. The last thing we need to talk about is magnetic fields on the molecular level. Basically, magnetic materials contain what are called domains. Now, what's a domain? It's just magnetic energy going in one direction or another. Now, each one of these little lines has its own little north and its own little south. If they are aligned, if domains are aligned, it's magnetic. If domains, on the other hand, are random and chaotic, it's not magnetic. So what that tells us is ferromagnetic materials that are very, very easily magnetized, it's easy to get those lines in those domains in line. So, in review, what is magnetism? Well, it's just simply an invisible force of attraction or repulsion. Flux lines are the invisible lines of force, and in a bar magnet or a typical magnet, they leave the north end and return to the south end. Everybody trying to get to the south side, Joe. And a couple other terms we need are reluctance, the opposition to a material offers to becoming magnetized; permeability, how long it does retain magnetic energy if it is magnetized; and then ferromagnetic, that's easily magnetized materials such as iron. We'll be talking later on about how magnetism and electricity work together, but basically what's really cool is if you take a magnet, some wire, insulated wire, and you move them in vicinity of each other, it produces electricity. That's called generating electricity. The inverse of that is true too. When electrical current goes through a wire, it tends to produce magnetic energy. That's main and most important principles in electronics. Thank you, and that's the Sorensen Quickie on magnetism.